Imagine building something as massive as a mountain, without cranes, computers, or steel. This was the reality for the ancient Egyptians, who became giants of innovation along the banks of the Nile. They saw the world as a grand cosmic puzzle, determined to solve it with their minds and hands. Technology isn't just screens and circuits, it's using knowledge to solve problems, and the Egyptians were masters. They harnessed the sun in their calendars, used water and sand to move stones, and built wonders that still amaze us. Their ingenuity wasn't limited by their tools, but by the questions they dared to ask. Let's journey back in time to explore the secrets behind their greatest achievements. We'll see how they built monuments that reached for the heavens and organized a society that lasted millennia. The pyramids are more than tombs, they're symbols of what's possible when people work together with purpose. The story of ancient Egypt is written in stone, papyrus, and the alignment of temples with the stars. They shaped their world, studying the patterns of the river, sky, and seasons. This knowledge gave them the power to build a stable, prosperous society. They created order, Ma'at, out of the chaos of the desert. In doing so, they laid the groundwork for future civilizations, including our own. Their journey is part of our journey. The echoes of their achievements still inspire us today. Let's begin our exploration of Egyptian ingenuity. The Great Pyramid of Giza stands as a testament to human ambition, a man-made mountain of stone. How did a civilization with only simple tools build something so massive and precise? The answer: planning, effort, and engineering genius. These projects took decades and involved tens of thousands of skilled workers, not slaves, but respected laborers. The first step: choosing the perfect location on the west bank of the Nile, on solid rock. To create a level base, they built a mud wall, filled the area with water, marked the level, then cut the rock flat. A simple, brilliant solution. Most of the pyramid's core was local limestone. The outer casing was fine Tura limestone, brought from across the Nile. Massive granite blocks for the inner chambers came from Aswan, over 500 miles away. Moving these stones required logistics, labor management, and clever use of simple machines. Construction was a marvel of organization with teams of quarrymen, stonecutters, surveyors, and transport crews. The entire operation was overseen by high-ranking officials, engineers and managers in one. Think of it as a national project, like a space program but building stairways to the stars. The pyramids symbolize the unity and power of the Egyptian state. Their construction remains one of history's greatest feats. Let's look closer at how they moved these stones. Moving multi-ton stones without wheels, the Egyptians used sledges, large wooden platforms pulled by teams of workers. Pulling sledges over dry sand was tough, but they discovered a trick: wetting the sand in front reduced friction by half. This simple act made moving massive blocks possible, a brilliant use of physics. Once at the pyramid, the stones had to go up, the most accepted theory ramps. But what kind? Straight, spiral, or internal? Archaeologists still debate. Ramps were made of mud, brick, and rubble, coated with clay for a smooth surface. Building and maintaining these ramps was nearly as complex as the pyramid itself. As the pyramid grew, so did the ramp, always providing a manageable slope. The scale of these temporary structures is staggering. A mountain built to build another mountain. The Egyptians adapted their methods as construction progressed. Their solutions were practical, efficient, and ingenious. Every stone moved was a triumph of teamwork and innovation. The process reveals the Egyptians' deep understanding of materials and mechanics. Their methods still inspire engineers today. The Egyptians built eternal monuments with surprisingly simple tools, mainly copper and stone. Copper is soft, so how did they cut granite? With patience, sand, and ingenuity. For limestone, copper chisels and saws worked well. For granite, they used copper saws with desert sand as an abrasive. The sand did the cutting. The saws wore down quickly, but copper could be recast. Tube drills, hollow copper cylinders with sand and water, let them drill holes and hollow out stone. Evidence of this technique is seen in the circular grooves left on artifacts. They also used dolerite pounders to chip away rock in quarries. Their toolkit was basic, but their skill was extraordinary. They understood materials perfectly, using the right stone for pounding, the right sand for cutting. Their technology was about mastering simple principles and applying immense human effort. The results: precision, durability, and beauty. Their methods set the standard for stonework for millennia. Egypt's story isn't just carved in stone, it's written on papyrus, the world's first true paper. The papyrus plant grew in the Nile Delta. Egyptians turned it into a smooth, durable writing surface. The process: peel the stem, slice the pith, layer strips crosswise, soak, press, and dry in the sun. The result: strong sheets glued into scrolls, some over 100 feet long. Papyrus was lightweight and portable, revolutionizing record-keeping and communication. Scribes became vital, managing the kingdom's knowledge and administration. Without papyrus, we'd lack Egypt's stories, poems, medical texts, and personal letters. Documents like the Edwin Smith Papyrus and Rhind Mathematical Papyrus reveal their scientific depth. Papyrus was the hard drive of ancient Egypt, storing its culture and wisdom. It allowed knowledge to be preserved and shared across generations. This simple plant changed the course of history. Through papyrus, Egypt's voice still speaks to us. The Egyptians were master sky watchers, seeing the heavens as both a clock and a sacred map. The sun, moon, and stars set the rhythm of their lives, dictating planting, harvest, and festivals. Astronomy was woven into their religion, government, and architecture. Their greatest achievement, a 365-day calendar, based on the heliacal rising of Sirius, which marked the Nile's flood and their new year. This calendar became the basis for ours today. Their cosmic knowledge shaped their monuments. The Great Pyramid is aligned with true north with stunning precision, likely using the stars. Temples like Abu Simbel were aligned so sunlight illuminated statues on specific days, marking royal events. These alignments were no accident. They were the result of meticulous observation and calculation. Buildings became cosmic instruments connecting earth and sky. Their understanding of astronomy was practical and spiritual. The legacy of their sky watching endures in our own calendars and architecture. The Egyptians turned the heavens into a tool for civilization. For Egyptians, math was a practical tool, essential for running the kingdom. Their base 10 system used hieroglyphs for each power of 10. Addition and subtraction were straightforward. Multiplication and division used a clever doubling system. This binary-like method made complex calculations possible. Math was vital for construction, calculating angles, volumes, and areas for pyramids and temples. The Rhind Mathematical Papyrus shows their skill with geometry and an accurate value for pi. Land surveying was crucial. After the Nile's flood, rope stretchers used knotted ropes to redraw property lines. This ensured fair taxes and prevented disputes. Their math brought order and fairness to society. The Egyptians' practical approach to numbers enabled their grandest achievements. Their legacy lives on in our own mathematical systems. Their numbers built a civilization. The Nile was Egypt's lifeblood, but its floods could bring both bounty and disaster. Egyptians mastered irrigation, turning desert into farmland and creating food surpluses. They built canals and dikes, channeling floodwaters into basins to enrich the soil. After the flood, water was drained, leaving fertile fields ready for planting. The shaduf, a simple lever with a bucket and counterweight, made lifting water easy and efficient. This device allowed a single person to irrigate large areas. To predict floods, they built nilometers, stone staircases with markings to measure water levels. Priests monitored the river, forecasting harvests and warning of famine or flood. The nilometer was an early warning system crucial for stability. Their water management was a triumph of engineering and organization. These innovations sustained Egypt for millennia. Their mastery of water shaped their civilization's destiny. Ancient Egypt's technological legacy still echoes in our world. Their achievements laid the foundation for future cultures, Greek, Roman, and beyond. Our calendar, with its 365 days, descends from theirs. Their medical texts influenced generations of physicians. The precision of their construction still inspires awe and study. Modern engineers follow in their footsteps when building dams or irrigation systems. Their use of simple machines, levers, ramps, shows the timeless power of basic physics. Egypt's story is one of human potential and curiosity. They saw tools in sand, knowledge in plants, and order in the stars. Even with simple means, they achieved greatness. Their spirit of innovation endures, reminding us what's possible when we dare to build and understand.